Hello students. So today we will be discussing about the periodic table. Last class we have discussed the questions regarding the S block and P block. Today we will be doing about the periodic table. So starting with 2021 questions. So the first question that from the periodic table that came in your exam was, what is the periodic property and how the following properties vary in a group or in a period? First was the atomic radii. Then is the first was the atomic radii. Then was the electron gain enthalpy and the electronegativity. Okay. So the question stated was, what is periodic property? So what is the periodic property? Periodic property. So periodic property is the recurrence or the occurrence of similar properties of elements at definite regular intervals with increasing atomic number. That is according to their electronic configuration, which is known as the periodicity. Any property which is periodic in nature, that is the periodic property. So recurrence of similar properties of elements. Similar properties of elements. Okay, that is at a regular interval. At a definite regular interval. So this is the periodic property, and this varies according to their electronic configuration. So when it varies according to the electronic configuration, that is called the periodicity. And any property which is periodic in nature, any property periodic in nature, what is that called? That is called the periodic property. Okay, so that is referred to as the periodic property. For them, they have asked that how the following properties vary in a group or period. First is the atomic radii. So what is the atomic radii? So atomic radii, they decreases, right? From left to right in period. Because with an increase in the atomic number in the period, the nuclear charge increases. And as a result, effective nuclear charge over the outermost electron increases. And due to this, they pull closer to the nucleus. And that is the reason decrease in the atomic radii is being observed. Okay. And atomic radii increases from top to bottom in group. Why does this happen? Because with the increase in the atomic number, the electrons are added to the new shells. This results an increase in the number of inner shells. So atomic radii increases in the number of inner shells, and hence atomic radius increases from top to bottom in a group. Okay. Next is the electron gain enthalpy. What is the electron gain enthalpy? So electron gain enthalpy increases in a period from left to right. Increases in period from left to right, because the size of the atom decreases and the nature of the element changes from metallic to non-metallic nature when we move from left to right in a period. And the electron gain enthalpy that decreases from top to bottom because there is an increase in atomic size. So this second element has greater electron gain enthalpy than the first element. Okay, so if you want to give an example, example is chlorine. Okay, chlorine. Chlorine has more electron affinity value, that is minus 348 kilojoule per mole, and then that of fluorine. Fluorine is, okay, so fluorine has minus 333 kilojoule per mole. What are these values? Electron affinity. Electron affinity values. Okay, so it is because fluorine is smaller than in size than the chlorine, and there is a repulsion between the incoming electron and the electrons already present in fluorine due to stronger interelectronic repulsion. Okay, next property what they have asked is the electronegativity. Right? So electronegativity increases from left to right. Increases from left to right in period. Why? Because the atomic radii decreases and the nuclear attraction increases. And in a group, electronegativity decreases from top to bottom due to the increase in atomic radii and decrease in the nuclear attraction. Okay, so this is the thing that this is the first question that they have asked you in their question. Okay, okay. So coming to the second set of this question. Second set, they didn't ask you any kind of question, but they have asked you one question, which is the discussing the position of the hydrogen in the periodic in the periodic table. So we know. So what is the question? Discuss the position of hydrogen position of hydrogen in the periodic table on the basis of electronic configuration. So hydrogen is the simplest element with one electron and proton. So what is the electronic configuration of hydrogen? It is 1s, right? So that this configuration is responsible for dual nature. Dual nature of hydrogen. Okay, so it behaves both like alkali metals and the halogens. So it can be placed along with the alkali metals, which is 1A, or along with the OR, okay, or along with the halogens, which is 7A. So what are the points that supports its position in 1A? Is that like alkali metals, halogen also has a single electron. The first point is, okay, let's do in the next page. Points to support 1A. So what are the points are? Alkali metal hydrogen has a single electron. Single electron in the outer shell. Outer shell. Right? So that is the reason we write it like 1s1. Okay. Second point is its ability to form hydrated unipositive ion, like H plus. In the aqueous solution, we write like H plus aqueous. Third is, it is quite reasonable to start the periodic table with an element that have the least atomic number. What is the atomic number? Which is 1. And what are the points that support 7a? So first point is hydrogen is a gas. Hydrogen is a gas like fluorine or chlorine, right? Hydrogen is a gas, we all know that. It can form diatomic molecules. Diatomic molecules like halogens, right? And most important point is it has a tendency to gain an electron and attain a stable electronic configuration of helium, because hydrogen is 1s. If it gains one more electron, it will be 1s2. 1s2 is the electronic configuration of helium. Helium is stable, we all know that. So that's what I am writing here of helium. So at times it is noted that hydrogen has not a great tendency to lose electron, right? This is also an important point. Hydrogen does not have a great tendency to lose an electron, like alkali metals, like the alkali metals, and gain an electron like halogen, and gain electron like halogen, right? So this is the very important point. So in view of this, it is very difficult to assign any definite position to hydrogen. Sometimes it is placed in 1a and sometimes it is placed in 7a group. Okay, so these two questions have come in your exam regarding the periodic table. Rest, I think none of the questions have come in this 2021. So let's now just move to 2020 question paper. So the 2020 question paper have asked you which hybrid orbitals are used by the carbon. Okay, let's just write it down. Okay, let's just write the question first. The question states that which hybrid orbital? Question states which hybrid orbital are used by carbon atoms in the following molecule. Okay, first is CH3, CH3. What is the thing? CH3, what is the name of this compound? It is ethane. In organic, I guess you have done. So this two carbon, here this carbon and this carbon, both has like this. Hydrogen, 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 hydrogen. So both these carbons have sp3 hybridization, right? Both these carbons have sp3 hybridization. Second is CH3, CH, CH2. So how will this look like? CH3, CH and CH2, right? So for this is called 1-propane. 1 propane. I hope everyone knows how to write the IPAC nomenclature. So this is 1, this is 2, and this is 3. So 1 is sp2, right? Second is sp2 again, but here it is sp3 hybridization. Okay. Third question that comes is CH3, CH2, OH. What is the name of this compound? It is called ethyl alcohol. Ethyl alcohol. Okay. So if you are calling this as ethyl alcohol, it has 2 carbon, 1 and 2. So 1 and 2 both will be sp3 hybridization. You can just check. Okay. So here hydrogen, 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 3 hydrogen, here 2 hydrogen, and this is OH. So this both carbons are sp3 and this is also sp3. So this is one of the question that has asked you in the exam. Okay. Apart from this, no other question has come in your exam from the periodic table. Okay. Now moving to the second, now moving to 2019. So in the 2019, let me just check with the questions. Okay. A very good question has come in your exam. Just wait for once. Sorry for the interruption. Okay, so the question that has come in your exam, that the question was why that what is the ionization enthalpy and why the ionization enthalpy is IE1 is like greater than why IE1, IE2 is greater than IE1 for the given atom, and discuss any 4 factors that affect the IE of the element. So what was the question? Question was define IE1 and IE2. Why IE2 greater than IE1 for an atom? And third is discuss any 4 factors that affect IE of an element. Okay, so how to write this answer? We know what is IE. What is IE first of all? IE is ionization enthalpy. It is ionization enthalpy. What is ionization enthalpy? It is the amount of the energy required to remove the most loosely held electron from isolated neutral gaseous atom to convert it into gaseous ion. So what is the other name? This is the definition. It is also known as the first ionization energy, right? So it is also called the first ionization energy. And why it is called the fast ionization energy? Because it is the energy which is required to remove the first electron from an atom. It is represented as I1 or IE1 and is expressed in what? Electron volts per atom, like kilocalorie, kilojoule per mole. Suppose M is a gaseous atom and I1 becomes Mg plus, this is gaseous, not magnesium, plus electron. So I1 states to the first ionization energy. Okay. And second part of the question is, why I1 greater than I2? The energy which is required to remove another electron from the unipositive ion. Okay, that is the second ionization energy. It is represented as I2 or I2, like M plus, which is in the gaseous state, plus I2, that helps to remove the electron, plus 2 plus electron. So this is the I2. So the second ionization enthalpy is greater than the first ionization potential, because on removing an electron from an atom, unipositive ion formed will have more effective nuclear charge than the number of electrons. So the effective nuclear charge increases over the outermost electron. Hence, more and more energy is required to remove the second electron. So this is the reason which shows that why the second ionization potential is greater than the first ionization potential. If you want to remember that for sodium, I1 for sodium, okay, I1 is 5.1 electron volt and I2 is 47.3 electron volt. So of course, like in general cases, I3 greater than I2 greater than I1 and up to IN. Okay, so this is the general reason. And what are the different factors that affect the ionization potential? First is the atomic radius. Okay, second is the nuclear charge, right? Third is the shielding effect, screening effect, or shielding effect, right? So these are the different factors that affects the ionization enthalpy. Okay, so they have asked you the names. These are the names. Okay, now let's move to 2019 second part. The first question that they have asked you, mostly these are the repetition. There is a repetition of the question. The repetition of the question is define I1, I2, why I2 greater than I1, and discuss the factors that affect the IE of an element. Okay, so this is just the repetition. This is just the question we have done just now. So this is just a repetition of the last question, like the first set that we have done. Okay, moving to 2019, the third set. So here, regarding anything which I can find is they have not asked anything regarding periodic table in the third in this set. They have asked a lot of things from the thermodynamics basically. So thermodynamics we are not revising today. Hopefully sir has done the revision of the thermodynamics, but apart from this, from the periodic table, nothing has been asked. Okay, nothing has been asked from the periodic table. Now moving to 2018, the fourth part, the fourth part clearly says again, okay, says one important question, that is, what is electron gain enthalpy and electronegativity, and how these two properties vary along the group and also along the period. So if you just already know, there is no problem, or you can just see how to write the answer. So the answer writing is quite simple. They have just asked you the two definitions of electron gain enthalpy and electronegativity. First is the electron gain enthalpy. Electron gain enthalpy. So the amount of the energy which is released. So amount of energy released when an electron is added to outermost shell of isolated neutral gas is called the electron gain and enthalpy. Okay, how does it vary along the group? In a group that is from top to bottom, this property decreases, right? This is due to increase of atomic size. And in a period that is from left to right. So along in a period from left to right, this property increases. In most of the cases, these things are just reversed, like along group, along period. The property tendency is just reversed. If it's decreasing somewhere, it is increasing somewhere. Okay, most of the cases, but in some cases, the properties stay same only. Next is the electronegativity. Electronegativity is the tendency of an atom. Okay, let me write. Tendency of an atom to attract the shared pair of electron. To attract the share towards itself. In a molecule. That is called the electronegativity. So in a group, how does this vary? So this property decreases. And along the period, how does this property varies? It increases. Okay, these are the variations. Just note it down for one. Okay, I think everyone has noted it down. So, next question from the 2018 again. Uh, there is one reaction, not there is any kind of specific questions they have asked, but they have asked how the properties vary along the group and along the period. So that one question we have already done. So the first thing that has been asked to you, how it varies, is atomic radius. Okay, so the atomic radius is, they decreases from left to right. Across period. Okay, and what happens from top to bottom? Increases. Top to bottom along group. Right. Okay. Then is the ionization enthalpy. Just now I have told that in a group, it decreases in the period, it also decreases. Electronegativity in group decreases, in period increases. Okay. So these are the questions that have come in your exam so far. Again, this next year same question has come. So that is, what is periodic property, how the following properties vary in a group in the period, explain, like in ionization enthalpy and the electronegativity. That is the exactly same thing that you are going to discuss, that we have written just now in the table. Okay. Again, I1, I2, they are just repeating the questions. Borax bit test last class I have done. So these are just the type of the questions that you will be getting from your question from the periodic table. Okay. These I1, I2 has come a lot of times. I have explained it also. If you have any more questions, you can ask, but these are the overall questions. Like, the periodic table is really a small chapter. So if you are doing the periodic table, just learn the definitions and the trend where and the exceptions. These are the three things you need to learn in the periodic table. If this is done, then you will be able to answer all the questions. Okay, so these whole of the previous year questions of the periodic table has been done.